Hello everyone, welcome back to my channel once again. As you can see on the screen, oxidation number. This is from the this topic from the class 11 chemistry first chapter. So as we have started already this chapter, so now we are learning about oxidation number. Oxidation number is also known as oxidation state. So before going to the direct definition of it, we will go to the indirect. Okay, so no, I am not taking here English lecture. This is only the chemistry one. So let's understand this reaction before going to the definition. So this reaction says 2H2 gas plus O2 gas, it gives rise to 2H2O which is in liquid. So in this reaction, this hydrogen from the reactant side, hydrogen atom is in neutral state which shows zero charge. Then that is in positive state. And also oxygen atom which shows 0 in negative, di-negative state, that is in negative state. So di-negative means two negative charges. So here it is assumed that there is electron transfer from hydrogen to oxygen, and consequently hydrogen is getting oxidized and oxygen is getting reduced. So we can see here complete loss of electron by hydrogen and gain by oxygen. So as we can say here, electron loss by hydrogen and gain by oxygen. So there is a formation of covalent bonds. Covalent bonds. Covalent bonds are nothing but sharing of electrons to form electron pairs from each elements. So let's understand these reactions. These are the similar one. H2 which is in solid form plus Cl2 which is in gaseous form. It gives rise to 2HCl which is in gaseous form. And CH4 that is in gaseous form plus 4Cl2 which is in gaseous form, which gives rise to CCl4 that is carbon tetrachloride which is in liquid form plus 4HCl that is in gaseous form. So here also from the reactant side you can see hydrogen and chlorine, these are having neutral charges, but after taking the electrons, after getting the electron, they are getting the different charges. So here from this reaction what we can say, there is a method. Okay, it is always assumed that there is a complete transfer of electron from less electronegative to more electronegative. What you have to remember, there is a transfer of electron always from less electronegative to more electronegative elements. So here you cannot remember each and every atom's oxidation number, so there are some rules, but before that let's understand this. Here I already took this one. So here you can see the charges. Okay, the same reaction is there. H2 plus O2 which gives rise to 2H2O. You can see the charges. Hydrogen shows 0 and oxygen also shows 0 charge. But after getting the electrons and after giving and losing the electrons, hydrogen has the +1 charge and oxygen get the -2 charge. Okay, now the second reaction about HCl, you can also see hydrogen is having 0 charge and Cl2 that is chlorine has having 0 charge, but after the getting electrons, hydrogen, after losing the electron, hydrogen gets the positive charge that is +1 and chlorine is getting -1 charge. The similar way the last reaction here CH4, here don't be confused, they are given here for the charges for each and every element. So in CH4 carbon and 4 hydrogens are there. So for carbon that is -4, this is the charge. As we know its valency is 4 only, so it is having the minus charge, that is -4, plus hydrogen is having +1 charge and again chlorine is having 0 charge. Okay, now after getting the electrons, okay, and after losing the electron, carbon is getting the plus charge that is +4 and chlorine is getting the charge that is -1, and again in HCl you can see +1 and -1 charges respectively. So the oxidation number, this is the definition. The oxidation number denotes the oxidation state of an element in a compound ascertained according to a set of rules. Okay, there are some rules formulated on the basis that electron pair in a covalent bond belongs to entirely to more electronegative element. So as we know the oxidation numbers definition, that is a sharing of electrons to each other, but this is a standard definition. Here you have to remember there is always a basis, that is the electron pair in a covalent bond belongs to entirely to more electronegative element. So this is one more definition for oxidation number. So let's see these rules. There are rules for calculation of oxidation number. These rules are: the first one, in elements in the free or combined state. Okay, when the element is in free or combined state, each atom bears an oxidation number of 0, as we saw in the reactions. Okay, so when they are free, they are not combined. Okay, so that time they are having 0 oxidation number. So evidently there are some atoms like H2, O2, Cl2, O3, P4 and S8, and also sodium, magnesium and aluminum has the oxidation number 0 when they are not combined. Okay, for ions composed of only one atom, okay, here we are talking about ions, the oxidation number is equal to the charge on the ion. How much charge is there on the ion, that will be its oxidation number. So thus Na plus, ion has oxidation number obviously 1, but plus 1, Mg plus 2, it having plus 2, Fe plus 3, ion having plus 3. Again Cl minus, only one minus is there, so that is minus 1, it is the oxidation number of Cl. Then O2 minus, Cl minus, sorry, O2 minus ion, it shows the minus 2 oxidation number. So here you can see for alkali metals oxidation number is plus 1, and for alkaline metals oxidation number will be plus 2, but aluminum shows plus 3 oxidation number. You have to remember. Okay, so third rule is there. The oxidation number of oxygen in most compounds is minus 2. Okay. In the case of peroxides and superoxides, peroxides means there is one more hydrogen. Okay. So the compounds of oxygen in which oxygen atoms are directly linked to each other, this is the superoxides. While in peroxide, that is example H2O2, Na2O2, each oxygen atom is assigned an oxidation number of minus 1. But in superoxides, example KO2, when there is one more oxygen, KO2, two oxygens are there, RbO2, that is two oxygens are there. So each oxygen atom is assigned an oxidation number of minus half. So for one oxygen is minus half, and the other one is minus half, it will become minus 1. Okay, but there is one exception again, when oxygen is bonded to fluorine. In such compounds, example oxygen difluoride, where you can see the two fluorines, and dioxygen difluoride, here you can see two oxygen, two fluorides. So the oxygen is assigned an oxidation number of plus 2 and plus 1. For OFT, that is plus 2, and for O2F2, that is for that is the oxidation number is plus 1. So here you can remember one thing, the number assigned to oxygen will be depend upon the bonding state of oxygen. That's why the oxidation number will be changes according to the bonding atom, and the number will be positive only. Now fourth rule is there, the oxidation number of hydrogen is plus 1 except when it is bonded to metals in binary compounds. Binary means having two elements. For example, in LiH, that is lithium hydrogen, sodium hydrogen. Okay, you can see here, and CaH2, its oxidation number is minus 1. Fifth rule is there, in all its compounds fluorine has an oxidation number of minus 1. Other halogen, fluorine is also halogen, that is other halogens are there, chlorine, bromine and iodine, also have an oxidation number of minus 1. But when they occur as halide ions in their compounds, they are having minus 1. And chlorine, bromine and iodine when combined with oxygen, for example in oxoacids or oxoanions, have positive oxidation number. So here what you have to remember, when they are in halide ions, always there will be -1 oxidation number, but when they connect with, combined with oxygen, there will be positive oxidation number. Okay, the last one, the algebraic sum of oxidation number of all the atoms. Whenever you are counting the calculation, you are doing the calculation of oxidation number, there will be the sum of its oxidation number should be 0. Okay, so it is clear that metallic elements are having positive oxidation number and non-metallic elements are having minus oxidation number. Okay. So one more I have to add here. You need to remember this sentence, particular sentence. The atoms of transition elements usually display several positive oxidation numbers, oxidation states or oxidation numbers. Okay, they are showing more than one oxidation number. So now you can see transition elements are in the periodic table in the group 8. So we'll discuss afterwards about it. So here you can see oxidation number is increases across the period. Okay, in the periodic table it will go horizontally, it will increases horizontally period to period. Okay, then across the period. Okay, then third period, that is the periodic table, third period shows the highest oxidation number. It goes from 1 to 7. So here oxidation number by an atom of an element generally increases across the period in the periodic table. In the third period, the highest value of oxidation number changes from 1 to 7. So here we have finished about the rules. So let's see one important question. Why iron, that is Fe, shows more than one oxidation number? Okay. Iron is a chemical element, as we all know, and it is having atomic number that is 26 and symbol is Fe, and it is a metal that belongs to the periodic table's first transition series and group 8. So earlier I just told you about the transition metals, transition elements are showing more than one oxidation number, and the metallic element shows positive. So we know here Fe is having positive oxidation number because it is metal, and also we got to know that it is in transition metals. Okay, it is a transition metal, that's why it shows the more than one oxidation number. So this is its electronic configuration, Ar, that is argon 3d6 4s2, and it is the extended electronic configuration for Fe plus 2. How Fe plus 2 is getting? So Fe plus 2 has the electronic configuration that is 1s2 2s2 2p6 3s2 3p6 3d6, while Fe plus 3 has the electronic configuration 1s2 2s2 2p6 3s2 3p6 3d5. So here you can see there is a difference between these two electronic configuration, that's why they are getting the plus 2 and plus 3, because in last valence shell you can see here 3d6. Okay, 3d6, so 2 electrons are not there, that's why it is getting the 2 plus Fe plus 2 Fe plus 2 oxidation number. And in for Fe plus 3 3d5, it's the last valence shell, so it is having 3 less electrons, that's why it is showing Fe plus 3 oxidation number. So when we compared Fe2 plus and Fe plus 3, so there are 2 fewer electrons in Fe plus 2, and in Fe plus 3 there are 3 fewer electrons. So in this way we got to know about iron, why it is showing more than one oxidation number, because first thing, it is metal, that's why it is showing plus oxidation number, and the second thing, it is a transition metal, that's why it is showing more than one oxidation number, because these elements shows more than one oxidation number, because they are having variable valence shell. Okay, they are having more than one valency. So as we know, iron shows valency that is 2, 3 and 7 also. Okay, so in this way we have finished about oxidation number. Okay, and one more video is coming on oxidation state. Yeah, I know oxidation number is also known as oxidation state, but how to calculate it? So in that video I am going to show you how to calculate oxidation number of any element. So thanks for watching, keep supporting.